Hello everyone, welcome. In this video, I am going to give a full introduction to databases. We are not going to discuss anything in specific, but I want to show you what databases are in general, how the databases are used, and why we use databases and different databases available to us. If you don't know anything about database, this video is kind of walk you through and get you up to speed with what you need to know so you can then go off and start learning how to use an actual database. Stay with me till the end of the video. I'll make sure you will get a clear understanding of what is a database in a simpler way. Before we talk about databases, let's understand what is data. By definition, data is collection of facts, numbers, words, or observations that can be used to learn about something. Technically, data is an unit of observation. Anything we observe is data. For example, if you look at a person, the height of a person is data. You can imagine there is a lot of information that we can gather when we look at a person, be it name, age, date of birth, height, weight, color, smoker, drinker, address, job, salary, food preferences, the car you drive, and a lot more. Each observation is a data point, and the data points combined together is called a data set. And this data can be of text, image, video, audio, and can be of any form. All the data that we are talking about now is raw data. It's simply a group of values or observations or any information or a fact. Raw data is not very interesting. It will become interesting when we start finding patterns in the data. For doing something with the data, like finding patterns, analyzing, generating insights, doing predictions, we need to store this data. That's where databases come into picture. We store the data in a database. So now the actual question, what is a database? The most basic definition is a database is collection of any information. Let's say you write a grocery list on a paper. Your paper is a small analog database or a physical database because it's storing your grocery list. In computer science terminology, it's a collection of information that's stored as data on a computer system electronically. When I say electronically, data is stored in the form of zeros and ones. Don't worry if you don't understand anything about storing the data in zeros and ones. That's way out of this topic. Just remember that we store the data in a database. For example, the inventory of an e-commerce platform like Amazon stores all the items available and the items that are out of stock in a database. When you open the application or website, you search for an item, the search is performed on a database and the results you see is the data that's fetched from a database. We often see database abbreviated as DB. So DB stands for database. And data in any form can be stored in a database. And data is not directly stored in databases, but every relational database stores information in the form of tables in a database. You can have many tables in one database, and each of your table can hold data which refers to similar objects. And each table has a name, and you can find out what kind of information is stored there. For example, let's consider the database of your university. It would include a table called students with all the data regarding students and another table named subjects with information on subjects at your university. And tables in a database looks exactly the way you would imagine a normal table. So they have columns and rows. Columns in every table have their names and they identify the kind of information that is stored in them. And each row stores information about one object. If you look at the student table below, you can see that the column names reflect the kind of data stored in them. So in the name column, there are names of students. And in the column phone, there is phone number of student, etc. Each row corresponds to exactly one student. And now you might be thinking that we can do all of these things in a spreadsheet or an Excel sheet as well. But there is a difference between a database and a spreadsheet. Databases and spreadsheets such as Microsoft Excel are both convenient ways to store information. But the primary difference between these two are how the data is stored and manipulated, who can access the data, and how much data can be stored. So the spreadsheets were originally designed for one user and their characteristics reflect that. They are great for single user or small number of users who don't need a lot of complicated data manipulation. Databases, on the other hand, are designed to hold much larger collections of organized information, massive amounts sometimes. Databases allow multiple users at the same time to quickly and securely access and query the data using highly complex logic and language. And databases might seem like a new and a different concept, but most of us interact with them every day. For example, We use databases when doing financial transactions. Banks use databases to keep track of customer transactions. Everything you perform on your bank account, from balance inquiries, deposits, withdrawals, to transfers between account, all these transactions need to happen almost instantly, and the data from huge amount of transactions must always be up to date. Imagine the number of people depositing the money in a day and number of withdrawals happening at the same time. It would be billions of transactions per second. For these purposes, banks use online transactional processing systems or OLTP systems that are built with relational databases, which can handle a large number of customers, frequent data changes from transactions, and faster response times. And another example is social networks. Almost all of us use social media these days. When you join a social network, let's say Instagram, your information is added to a non-relational database of everyone who uses that network. When you connect with other people in that network, you will become part of a social graph. That is why you are able to see the filtered list of your friends or professional connections and discover new people who are connected with your friends. Any information that's being shown is actually retrieved from a database, and any information you enter in the application will be stored in the database. And these databases will be storing huge amount of data, and these would be installed on large servers. Whenever you search for a post or a friend, Instagram actually searches for this data in the underlying database. And next comes DBMS. You might also be hearing a lot about DBMS when you talk about databases, and you might be assuming that database and DBMS are same, but they are not. Database is a container that stores data. DBMS is a software that's used to manage your database. So a database is basically controlled by a database management system or DBMS, and you need this DBMS to interact with your database. And DBMS is also used to create and manage databases as well. Examples of databases include MySQL, PostgreSQL, MongoDB, Neo4j, Cassandra, and there are many more to talk about. And let's also have a look at the database types. Broadly, databases are categorized into relational and non-relational databases. Relational databases are highly structured and understand a programming language called Structured Query Language or SQL or SQL. And non-relational databases are highly diverse, supporting a variety of data structures. And since many non-relational databases do not use SQL, they are often called as NoSQL databases. Relational and non-relational databases differ on how the data is stored in them. Relational databases store data in the form of tables, and tables are basically a way of organizing data into rows and columns. And column has a name and a data type, and data type is just the role associated for that column. So every column in a table in database has this data type, and the data that satisfies this rule can be inserted into this column. A row is basically called a record, which is formed by single or multiple columns. It's very similar to how data appears when stored in an Excel or spreadsheet. And this structured data is both efficient and flexible to access. And examples of relational databases include SQL Server, Azure SQL, MySQL, PostgreSQL, MariaDB, IBM DB2, and a lot more. And then comes non-relational databases. There would be some use cases where SQL databases are not required or not compatible. Let's say we want to store some image data, and this does not require a structure and can be stored as a key value pairs. And non-relational databases store unstructured or semi-structured data. They don't use tables with columns and rows the way the relational databases do. Instead, they use a storage model that's optimized for specific requirements of the type of data being stored. And non-relational databases allow for larger sets of distributed data to be accessed, updated, and analyzed quickly. And various types of non-relational databases include key value databases, document databases, graph databases, wide column databases, time series databases, and each of them store data differently and are used to manage different kinds of data, and all these databases are called non-relational databases. And examples of non-relational databases include MongoDB, Azure Cosmos, DocumentDB, Cassandra, Couchbase, HBase, Redis, and Neo4j, and many more. Some non-relational databases are referred to as NoSQL databases. NoSQL refer to the data stores that use NoSQL or not only SQL for queries. Instead, NoSQL databases use other programming languages and constructs to query the data. And many NoSQL databases do support SQL compatible queries, but the way they execute these queries is usually different from the way traditional databases would execute the same SQL query. Now that we have seen what databases are, the next thing is to learn actually how to work with them. I would show you how to do it, but honestly, the best way to learn is by doing. So in this series of videos that comes after this, I'll be teaching from basics to advanced level and will guide you through the installation, setup, and writing basic SQL queries to advanced SQL queries and working with databases. And that's it for today's video.